Sorry.
All right, so first reminder, the grading of homework 3 is due today at 6 p.m. Another reminder is that the total is still out of 20. However, in the first problem, instead of half points for each one, it's 1 point for each one. So it still totals to 20. Especially because that's a fairly straightforward problem, you should be happy about that. So you get more credit for that one. The second thing is homework 4 is not due at 6 p.m. Only your grading of homework 3 is due at 6 p.m. because you probably want to look at other people's feedback on your project ideas before you do your final sign off on your project. So I just made homework 4 due a little bit later. I mean, you could ignore this and still be done by 6 p.m. But I'm not going to actually collect it until Sunday at 6 p.m. Okay? So just so you know, if you need a little more time on the last homework or you want to wait to see the feedback, wait until Sunday. You'll see the feedback you got from other people by Saturday morning. Or possibly at 6:01 p.m. tonight, depending on what I'm doing. But if I'm not at a computer, it'll be Sunday morning. Okay? Let's see, next I have created the next homework assignment 5. Let me show that to you. So this is homework assignment 5. To make it easier when you're grading, it has the total x/20 filled in already. So obviously you don't start the assignment by putting a 20 there, but that's what you want to aim for. Okay, so here it is. I'll just quickly go over the problems. Looks like I wrote homework 4 there mistakenly. But I should say homework 5. And of course you don't have to do that. Okay, so problem 1 involves the command line. It's basically some very basic exercises to practice using the Unix command line. After what I'll show you today, you'll be able to do all of these and much more with ease, I hope. So these are just some basic exercises using the command line. The second problem is to do exactly the same things you did in problem 1, but using Python, for example, the shutil module in Python, which you already know how to use. It's just that you can compare and contrast the two approaches to doing things that involve the file system. Okay, and I see that I made a typo in the word problem, which I can now fix. Problem 3, since we're going to start talking about Git early next week, will be to find a tutorial about Git and read it and then make some comments on it. You might say, I read this tutorial that I found and it sucked, and here's why. Or this was the best tutorial I've ever read. Whatever, just say something about, was it good, was it bad, what did you learn? Okay, and you can choose any tutorial at all that you want. Of course, we'll be doing tutorials as well in here. Second, make an account on GitHub, which is free, and just create some basic GitHub project for, doesn't really have to have anything in it, but where you'll end up posting your final project for the class. Okay? Unless you're one of the people that is apparently boycotting GitHub, in which case, if you are such a person, well, you can use Bitbucket or something, but most people should use GitHub. Apparently, some people are boycotting GitHub, as I learned reading the news on the way over here. Finally, there's a problem about your project. So the first part is to list the format of what you're going to deliver as your final project. So it could be, there's many different possibilities. It could be a Sage worksheet. It could be like a paper written, say, using LaTeX. It could be some modifications or bug fixes to Sage. It could be a program written in JavaScript that's completely separate from Sage, etc. But you should describe what your deliverable, so to speak, will be. Okay, so that's the first part. The second part, if you're going to collaborate with other people in the class, that is entirely possible. You should list these people at this point. When you turn in your project, it's going to be completely your stuff, and you'll be graded on what you turn in. You won't turn in like a single merged project, even if you're working with somebody else. But if you're working with somebody else, they're probably going to be doing one specific thing. You're doing another. And what you'll do is you'll turn in the whole thing and say, this is the part I did. And that's what you get graded on. And then you'll have like a copy of the other person's stuff. Okay? So, for example, if you were to write a paper, then maybe one section or two sections would be by one person and then two sections by another person. I know that's not how papers are really written in real life, where often two people sort of do a lot, but you are allowed to collaborate with other people in your projects and encouraged to do so if you want to. But you don't have to. It's up to you. And then create a timeline for how you plan to actually make a first rough draft of your project. What are you going to do to go from now until you have a first rough draft? Remember, the first rough draft is due in about 2 weeks. Okay, so that's the last problem. And it's due on a specific day, that day being May 9th. So I guess that's 2 weeks from today. First rough draft. That's not the final. The final project's not due until like the last day of class. Or very close, not the last day, but very close to the last day. Okay. Any questions about the homework assignment? Any questions about other things? Yes?
On the last homework assignment, you need to plot something.
Yes.
Is it possible to test a plot in your doctrine, or does that only work for the text?
It's possible to test that the plot command didn't blow up and give a traceback, but it's not possible that it actually plotted the same thing it did last time. It would be cool if it were, but let's see. Yeah, I don't think we ever really figured out how to do that. You would have to generate a small version of the image and save it somewhere, and then like in some cache directory, and then it gets complicated. But it could be done. It hasn't been done for Sage. And a lot of plotting is randomized, but there is a fixed random seed that's the same whenever the doc test gets run. So that wouldn't cause trouble. But you'd have to decide on like whether it's a PNG image or an SVG file, or what are you going to compare against to say whether it's correct or not. And then when things change, they can all change, so you have to redo them all. Like every time the matplotlib library gets updated. Yes?
The two classes that we have to write the homework also say that they should only take rationals.
Yes?
Would that be rationals, real numbers, everything that's, because those aren't necessarily subsets in the time system.
Use your judgment. But don't make the A and B in your things floating point numbers. They should be exact numbers, like integers or rationals or whatever.
Is there a way to test for two instances of like one or another class?
Yes, that is a very good question. Let me answer that over here. And I did mention that briefly, but I'll remind you. Let's suppose you want to decide whether something is an int or a long or a Sage integer or a rational. You could do the following. If is instance, and the something, I'll just call it something, int long rational integer. So that will be true exactly when something is one of those types. So this should print yes, assuming I am. I think of no reason why this wouldn't work. Come on. Okay, so just had to connect. So, and it'll also say yes if I do 5/7. But if I do 5.5, it'll say, it won't say yes. So I'll just say else. Nope. Okay, so that's the answer. Is instance your thing, comma, and then a tuple of the different types. And this is better. It doesn't just test that it's equal to one of these types. It tests that it's any class. It's an instance of any class that derives from any of the listed types, which is really what you want, because the user might make a type that derives from integer or rational or int that adds some extra structure to it. And because of the ISA relationship with inheritance that one should always maintain, anything that derives from one of these should work in your code as well. Unless the person did something really stupid. Okay, so that answers your question. Other questions? All right, so now we're going to talk about the command line. I will assume that you have never used the command line at all and have no knowledge of it, even if you do. So first, some overview. So I'm going to talk about bash, which is an abbreviation for the born again shell. It's a particular command line shell. It's not the only one. There are others. I think this one's by far the most popular. It tends to be the default. Like if you use, it just comes by default with OS 10, with most Linux distributions, etc. But some people like other ones for some reason. The command line. This is the thing that you get when you click the plus new button up there, and then click on command line terminal. So you'll get a command line. It's also what you get when you, in OS 10, for example, if you go to Applications, Utilities, and then Terminal. If you click there, you get something. It pops up. Well, it was already open for me, so here it is. And it's a terminal, and there you have a program is running, ready to take my commands, and that program is called bash. Yes?
What's a shell?
What is a shell? It's kind of a philosophical question.
Like a wrapper for
Yeah, I mean, something that you use to launch other commands. It kind of provides an interface between you and the operating system, I think. So I don't know if there's a formal definition of shell, but I mean, it really, what it accomplishes is the following. You have the operating system, which the responsibility of the operating system includes things like open a file, run a program, make sure there's enough memory, blah, 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 allocate resources. And then it's sitting there and you need to interact with it, and there are various ways to do so, and the shell is one of those ways of doing it. And typically, when people talk about a shell, it is a command line shell. Because the graphical user interface is really another way of accomplishing pretty much the same thing. So if I go to Finder, for example, and start clicking around and looking at files, I'm looking at files on my computer. I can open files. I can accomplish this sort of tasks. The graphical user interface, Finder, is a program that lets me accomplish certain tasks involving the operating system. Okay? The terminal is a different approach to exactly the same problem. You want to accomplish some tasks, like you want to rename a file. You want to copy some files from one point to another. You want to delete some files. You want to find files with certain contents in them, etc. You want to make a directory. They're standard things. You can do many of these things with a graphical user interface. If I want to make a directory there, everybody knows how to do that. You right-click, or you go up to the top and do new folder or whatever. The command line terminal is a different approach to solving those same problems. That's, of course, actually dramatically older. This Unix shell is something that goes back to the 60s, whereas graphical user interfaces are a lot newer than that. Of course, they're like the 90s. So they're all old, but they're not as old. But the interesting thing is that these two approaches, the command line shell and a graphical user interface, though they more or less allow you to solve the same problem, they are extremely different approaches to that problem. And so certain problems are much, much easier to solve using the command line, and other problems are much easier to solve using a GUI. If you're a graduate student, I would tell you all that it's kind of like you have a functor between two categories. And in one of them, certain math problems are really easy to solve, but others are really hard. And in the other one, certain math problems are easy to solve and others are hard, and they're completely different. So in math, at least, like in math research, very often the major advances come by transforming a problem in one area to a problem in linear algebra or some other area, and then suddenly things that were hard become easy. And likewise, often you can accomplish things using the command line shell that are extremely painful to do with a GUI, and conversely. Okay, so it's worth learning. It also provides you with a whole bunch of tools and programs that you would never have access to at all and are extremely powerful in some cases. Mainly because a lot of people have written programs that only work here And then what often happens is if they're very, very popular programs, somebody will write a version that works with a graphical interface but has a often fairly restricted feature set compared to what's available over here. And so you really just have a very different and wider, in some ways, choice of software tools available to solve certain problems. Okay, so that's kind of just a little pitch for why you might want to learn something about the terminal. An example of such a tool, by the way, is Git, which is a program for tracking the changes to a collection of files and sharing files with other people in a collaborative way, as you'll see. So most of the things that I'll show you, you can do in a Sage Math Cloud worksheet or an IPython notebook by putting an exclamation point at the beginning of a line and then putting the command. But I'll do most of them in an actual terminal. But I just wanted to point this out. Okay, so here is a rundown of how things work. I'm going to show you all the most basic commands. And there's no way you could be at all proficient with using the command line terminal without really memorizing these commands. But fortunately, the total number of letters of all the commands put together is like less than my name, so it's not like there's a lot. That said, the commands themselves, I'll just show you their most simple invocations, but they each have a number of options that can be very subtle, and there's pages and pages about how they actually work. So here are the commands, but first the way it works is you type in a command and then you see some output. So just to see that very quickly, we go to the terminal in OS 10. I can type a command, ls, 2 letters, ls. It's an abbreviation for list. And what it does is it shows me all the files in that directory. The directory you get by default is your home directory on the computer. By the way, just for fun, let me show you a little screenshot on Wikipedia. Right, this is a program that was written in 1979, Unix version 7. And here's an example of typing ls. You type ls, and then some options to it, and then it gives you a list of files. I tried exactly the same command a few minutes ago in Sage Math Cloud, and here's what it looks like. It's almost identical, and that's 35 years later. So this command line terminal stuff has been around for quite a while. And when things have been around for a while and they're stable, like you type the same commands as you would type in 1969 and they work perfectly, then you might have, then first learning it is going to be valuable because you can learn this stuff and when you come back to it in 5 years, it's going to work perfectly. And programs you write against it will work perfectly. And it will work fine on a multitude of different operating systems. And so there's a lot of pluses to that. And also a lot of stuff has been built on top of this command line environment. Windows is a completely separate world. Basically, nothing I'm talking about works the same in Windows, unfortunately. They have a completely different perspective. Okay, so that's the one caveat. Although you can install an environment called Cygwin into Windows, which then allows you to have an interface to Windows that does work just like this, and in fact uses bash. Okay, so here are the basic commands. And I'll illustrate all of these in a minute. pwd, what that does is it prints your working directory. It's kind of like if you're in the Finder or File Explorer or whatever in your operating system, that's the current directory that you're in. So when you use bash, the command line prompt, you kind of imagine that you're walking around in your computer and you're in a current room, and that's like the current working directory. So pwd is print working directory. ls lists the files in the working directory. These are the most basic forms of the commands again. Like ls can take an optional path, and then it lists the files in that directory, not in the current working directory. And then in addition to that, you might want lots of extra information about the files, or you might want to sort them in a certain way or whatever, and those are just little options to the ls command. There's a cd command. If you say cd, that stands for change directory, and what it does is it moves you from directory you're in right now to another directory. Just like clicking on a folder or clicking on the up button in the Finder moves you from one directory to another. And by the way, you can write programs in the bash language that use all of these commands, which is something that's kind of like making a macro or something, like recording a sequence of actions in a graphical interface. However, it's a lot easier to deal with because it's just a sequence of commands. So you can easily just modify it a little bit. Whereas with a recorded sequence of actions, it's pretty painful to just modify little bits of it. Another command is move, mv. So far we've gotten up to like 9 letters. So mv, what it does is it takes a file or a couple of files and then a destination, and it moves the files to that destination. Simple as that. So it lets you move files. Copy, the command is cp, which is an abbreviation for copy. It's similar to move, but it copies a file or a bunch of files to some destination. mkdir, that makes a directory. So you type those 5 letters and the name of a directory, and boom, you have a directory. rm, that removes a path, or if you say rm and then give these options, -rf, you can remove a directory even if it contains lots of things. For example, if you are using the command line on your OS X computer and you type the following, couple of letters, you probably are in for a bad day. So what this will try to do is delete every single file on your whole computer that you have access to with no prompting at all, with no trash can. It just deletes everything. And it's, it's not very many characters. And this does happen to people. For example, you can write a program that constructs a remove command, and you have some mistake where you accidentally have a space here or something, and it ends up doing this. I know somebody works at a hedge fund in New York that said he ended up doing this to one of their computers. He ended up leaving for some reason. So that's just an example, but it's extremely powerful what you can do with just a few characters. Like, you're not going to do something so destructive, probably in the Finder, but if somebody borrows your computer and opens the terminal, watch it, because the few characters, it can do a lot of damage. Another very important command is man, M-A-N. That stands for manual. You say man, and then you give the command. And that gives you lots and lots of information about the command. It should comprehensively document all the features. And because this little suite of software has been around for decades and decades, and a lot of people with high standards have looked at it repeatedly, the man pages are actually pretty good. They're pretty clear and useful. So they really comprehensively document everything. And also, like in Google, for example, if you just say man in a command, you'll find a couple of websites that give you the same sort of documentation. There's a lot of really cool stuff related to the command line that you can find online. I'm just going to record quickly on the whiteboard the commands I just mentioned, and then show you some examples that involve using them. So pwd, print working directory, ls, which lists the files in a directory, cd, that's the command that lets you move from one room to another, ls lets you look around, mv allows you to move stuff, cp allows you to copy things, makedir allows you to make a new room, rm allows you to kill things, and man allows you to read the instructions. So it's actually a lot like those text adventure games, if you've ever used those. Except when you kill stuff, it's gone forever on your own computer. Nothing moves to the trash automatically when you use these commands. Okay, so let's just try out a bunch of these things. So I'll type +new, then command line terminal, and I'll make it big. By the way, for each terminal in Sage Math Cloud, there's a corresponding file. I just created that file right there. If you're collaborating with somebody on a project and they open the same file, then you both can see the keystrokes at the same time, and one person could type and the other person could see it, and vice versa. So that can be useful. Also, if you do some stuff, as long as the project's running, if you close this, close your browser, whatever, when you come back later, let's see. So let me get back to that directory. If you come back later, it should look just like how you left it. This is not the case, though, if the project shuts down because you've left it for a long time, which or the server it's running on reboots, then that state will go away. The state's only maintained as long as the computer's running and the project inside of it's running. I send everybody's projects in here so they don't time out ever, so you won't notice that. But if you do a bunch, it's really important. I want to really emphasize this. If you do a bunch of stuff in the terminal you may want to copy and paste it out into a file. Don't expect it to just be there. It's a very common misconception that anything you type here is just going to be here forever. There's a scroll back history. Like if you type something, if I type this a few times, I'll get lots of text. I can scroll back and see previous stuff. So you can scroll back and forth. However, that also has some cutoff. If you have a whole bunch of outputs, then at some point it starts truncating the history at about 400,000 characters. So this is the case with most of these terminals. They don't save the output unless you do something very explicit to save it. With SageMath Cloud, I do plan to have it save the logs of terminals in the project. It's just not implemented yet. Okay, so now let me illustrate each of the commands here. So pwd will print the current working directory. Actually, I'm going to switch to do this demo in the public or in our shared project. So if anybody wants to, I guess, tune into the same terminal, they can. I'm just going to use the terminal wstein at the very top. Okay, so print, whoops, print, wait, what? Okay, pwd, what is this all? Okay, so pwd prints the current working directory, pwd, that's the directory that we're in, and it's an absolute path on the file system, so it's like, in this case, the home directory for the project is /project/ the ID of the project, and then the particular subdirectory that we're in. Okay, so that's where we are. So that's what pwd does, print working directory. ls will list the files. ls. Oh, somebody typed it already, thank you. I thought I was crazy. I didn't type it right before I typed it. Okay, so ls lists the files in the current directory. Some shells will do some sort of syntax highlighting. Notice that the homework and lectures are in a slightly different color. And for me, they're light gray. If you go to your account settings and in the upper right, there's a terminal color scheme. So yours will probably look like default black on white. That's the default. So it'll look a little bit different. I'm going to close this and reopen it so I see that version. Okay, so, it's annoying. Okay. That is a bug. These are control codes that show how this, that determine colors and so on, and in some cases they're just getting displayed rather than interpreted by the terminal. But you really shouldn't ever see those. It used to be a lot worse, but I've eliminated most issues where those appear. You can resize this and so on. Okay, so there's some syntax highlighting and coloring here. For example, poll is an executable file, which I could run. It's a program I could run from the terminal, and that's why it's green. That's the color to indicate that's different than the file readme, which I can't run. If we type ls with some options, ls-l, what that will do is give us a listing of the files with additional information about each file. So it tells us who owns the file, what group the file belongs to, the date that the file was last modified, and the very left has a sequence of codes that tell you about that it's a directory. It tells you about the permissions on the file, read, write, execute, for the user of the file or the owner of the file, the group that the file belongs to, and other users not in that group. And so that's what those funny codes mean on the left. And if you remember the picture from Unix in 1979, they're the same, exactly the same back then. Okay, so this just tells us a little bit more. Notice that, for example, the poll command has these X's here. Those X's mean that it's an executable file, whereas these don't have X's, so that file is not executable. Right, so that's the ls command. And again, there are lots of options for these commands, and I used one of them to see more information here. CD lets us move around. So let's see, so lectures is a directory. So I'll type CD, and then I'll give the directory lectures. And what that will do is move me into the lectures subdirectory. I'm going to move the screen up a little so you don't have to look at the bottom. Okay? Notice that the prompt has changed. The prompt is 100% extremely customizable. You just have to set a certain variable with a pattern, and you can make it have whatever information in it you want. What it does by default here is give us our current working directory. It's basically giving us the output of PWD. Now we're inside of the lectures directory. What is an instinctual thing to do at this point? Yeah, LS. You walked into a room, look around. Let's see what's there. Oops. So you look around, you see that there's 12 subdirectories with various names and a file. Okay? And now we've done something. And by the way, if you want to go up, if you want to go to the directory one level above the one that you're in, there's a special name for it, which is ... So that'll move us back up. So I'll just write, we just moved up one directory. That's kind of like, hitting the, I don't know, back or up or whatever in the Finder. Okay, so now we're in lectures. You can change into any of these directories. But let's see, what else do we have? So we have lscd, mv. mv lets us move a file. There's no rename, you just move a file. So let's do something annoying, which we'll fix in a minute. Let's move the videos file inside of the directory 2014-0425. Okay? So what you do is you say mv, and then you can start typing the name of the file and hit the tab key. Bash has nice tab completion, just like Sage or IPython or any of these other programs. So I didn't type in the whole word, I just used tab completion. You should very, very, very frequently be hitting the tab key if you're using the terminal. It'll save a lot of frustration. Then I'll type in 2014-04-25. And then I hit enter. And now the file is moved. There's no feedback at all, unless it fails. With the command line terminal, if things work, you get absolutely no feedback at all. It's just no error, nothing happens. If nothing happens, in most cases, that means it's really good. So now we'd like to confirm that this really got moved over there. So we'll type ls to C. And it's gone, so that should make us feel great. But we might be worried that we accidentally typed remove rm rather than mv. So we'll look inside the directory, 2014-04-25. And there's the file, videos.md. Notice, again, I used something beyond just typing ls. If you type ls and a path, it tells you the file's in that path. So you don't really need to know about that. You could have just CD'd into that directory and typed ls, but it's a little bit quicker to be able to just type ls without having to change into that directory. Okay? So now let's move that file back, and we can do the following. mv get the file, and then say dot. Dot means the current directory, the directory that we're currently in. And now the file is back. So there's two things that I didn't write down yet, and I just said in words, which I will now write down, which are also really important to memorize if you want to use the command line. Dot equals, so single period is the current directory. It's like a shortcut. You could, of course, write out the entire directory name, but that would be very tedious. And the other thing is 2 dots represents one directory up from where you currently are. Dot, dot equals one directory up. Okay. So let's see, we haven't used copy yet, cp. So let's make a copy of the videos file. Cp videos to foobar. Call it anything we want. And now, typing ls, we see that there's a new file, foobar, which we just created using the copy file. And it's the exact copy of videos.md. It just doesn't have to end in .md. Okay, so that's how you copy a file. And you can also copy a file into a subfolder. Oh, notice, by the way, what I just did here. Well, unless you were watching my hand behind this black box, you probably didn't notice. If you use the up and down arrows, you can scroll through all the past, or at least the last 1,000, I think, past commands. So if I hit the up arrow, I see my last command. If I hit it again, I see the command before that, etc. So it's nice to have this history. And you can also just type history. If I type this, hundreds and hundreds of lines are going to fly by, and we'll see the very bottom of the last few hundred commands that we executed. I'll do it. Okay, so there are 110 commands in the history, labeled with numbers from 1 up to 110, and there they are. These are all the inputs that we gave, and in previous sessions were given. Except for some subtlety, if you're running multiple bash programs at once, it's a little bit subtle about how the histories get merged and so on. And it's similar if you look at, I just want to emphasize that everything I'm doing, if I use the terminal in OS 10, it's identical to what I just showed you. There's history, there's ls-l, it's all exactly the same. Or if you're using Linux, which of course we're actually using in Sage Math Cloud, then it's again exactly the same. Okay, so let's see, we used copy. I think I left something laying around. Type ls to see. That foobar thing. So now let's use remove, rm. Rm removes the file, and we'll type rm and then foobar. And it silently just does this. It doesn't say, hey, we removed your file. It just does it. If you try to remove something that doesn't exist, then you'll get an error. But you only get errors when you only get any output at all when things go wrong. When things go right, you don't get anything. Let's see. And then man, I haven't showed you any, make dir. Let's do make dir. mkdir, that makes a directory. So let's make a directory called something random. Now if we type ls, we'll see that that directory is now there. Okay. Now imagine you wanted to, I don't know, make a whole bunch of directories with certain properties or something. You could just write a little script that would do make dir a bunch of times and make directories. That's something that's kind of hard to do with a graphical interface, but pretty easy to do here. Okay, so we now have a directory. There's one thing, if you do remove and then give the directory name, so I'll use up arrow and type rm, this will fail. Remove only works on files. If you don't give any additional options, it only works on files. So it just says, sorry, I'm not going to do that. However, if you do remove and then give the R option, so remove -R, then it will recursively go through and remove the thing that you gave and anything inside of it. And hence, it will remove our directory. Okay. You could even do remove -R on this directory, but I probably shouldn't. I'm so tempted to. I'm going to do it anyways. Whoa! I pasted in something. I didn't copy first. Remove -R. So that's pretty dangerous. What have I done? Okay. I did remove -R and then I pasted in the wrong thing. I'm just begging for death. So that's a danger of these commands. Often, you want to paste something in that's one of the arguments to your command. But your paste buffer, your copy buffer, may contain something completely different because you forgot to do a copy. And so if coincidentally the thing that I just accidentally pasted in, which was in fact the title of a blog post I just made, had contained a slash symbol, I probably would have deleted all the files accessible to this user. So it almost just happened to me. Luckily, it turns out that the names that got pasted in weren't slash. So if I had said the Sage Math Cloud /roadmap, it would have been game over. In that case, there is the snapshots. If you go ls tilde/.snapshots, tilde is one other thing. That's your home directory. It's a tilde symbol. Tilde. This equals your home directory. So that's like the place you start. So inside of there's a subdirectory snapshots in Sage Math Cloud, but almost certainly not on your laptop. And in there, there'll be lots of files. If I type ls, I'll see them. And these are read-only, so there is no way to delete them by accident. So I could just go into one of these subdirectories, get the files that I accidentally deleted, and put them back using the copy command. Or, of course, I could directly do it with the graphical interface. Okay, so I've showed you everything except man. Let's see, let's do man on one of these commands. How about ls? So think of it this way. It's like ls is some command that lets you look around in a room and tell what's there. What are the options? What can you see? So if we type man ls, that will tell us all about the ls command. It should be a relatively simple one. So ls list directory contents. It has some options and it takes files as input. And then there's a description. There's actually a bunch of options here and some other stuff. And let's just start paging through this. So you have to hit the space bar or the arrows to move up and down. And you'll see that there are lots of options. There's a very standard, uniform way in which the options are specified. You do dash and then a single letter, and you can combine those, or you can do double dash and a word. There's like a verbose version and a non-verbose version. And it's very consistent how the arguments are specified throughout the thousands and thousands of commands in Unix. So -a will list every command, every file in the directory. There are certain files that start with a period, which are hidden by default. Just like in OS 10, for example, files that start with a period, you don't see them in the Finder. You have to click some box to see them. Similarly, that's the case with the ls command. If you do -a, then you get to see those files as well. And then there's a bunch of other things. So some of these I've never thought about or ever used. I've never used -b. I've never used --author. I've never used block size. I've never used capital. I've never used most of these actually. So there's tons of options. There's one funny one, human readable. You'll find this option often with Unix commands. By default, often the output of Unix commands is not necessarily designed to be human readable. It's designed to be program readable in that there's a really clever way in which you can combine together these sorts of commands and the thousands of other Unix commands to make bigger things all in one line. And it's kind of like composition of functions in mathematics, or calling a function and then calling another function on the result of that. So you can, for example, take the output of ls and feed that into another program that sorts the files or searches for a certain pattern in them or whatever in the output of ls. And the command that allows you to do that is called the pipe. It's just a single vertical bar, and on my keyboard it's shift \. So this is the pipe command, and we'll get to that more next week or later today. But it allows you to string together multiple commands. And the human readable stuff, often that's when you want to use a command and have output that's really easy for a person to look at, not for another command to use as input. Okay, so this goes on for a while. There are a lot of options, and you'll find that this stuff is so mature that in many cases, every possible reasonable option you can think of has been implemented, documented, and debugged by now, which is not the case of a lot of software that you use these days. So it goes on and on. You get to the bottom. Do read the line at the bottom. It says push Q to quit. You really have to do that. I've seen people get stuck in this sort of thing, and it's kind of sad. Okay, so now we know there's ls-a that shows us all these hidden files. There's all kinds of stuff. ls-h or L, that'll give us human readable file sizes, I guess. But that's kind of overwhelming. Just the human readable output, it looks the same. This is pretty human readable, etc. Okay, so let's see. And every single command has a man page, like the one I showed you. Let's see, another important thing is copy also has a -r option. If you want to copy a directory, it won't work if you don't use the R option. If you do cp, so it worked fine with a file, but if you try to give a directory, that fails because it won't recursively copy inside of it unless you explicitly tell it to. If we want this to work, you just have to give the -R option. And then it does work. Now we have a new directory. Foobar. Okay. And remove -RF foobar. Whenever you type remove -RF, you want to pause for a second and think. Because remember, if I accidentally put one space there, I would suddenly delete every file on the entire computer that this account has access to. So it's pretty terrifying, but powerful. It's kind of scary to use the command line if you don't have a snapshotting system or some sort of thing making regular backups. Fortunately, SageMath Cloud does. But when they designed this, they made it with computers that were like maybe no screens at all, or very, very slow modems or whatever, where every keystroke, you had to think about exactly what you wanted to do and then enter it, and with a minimum number of keystrokes. And so they didn't mess around with, oh, do you really want to do this type of stuff. Okay, so there we are. Let me show you the next section here. Okay, so that's the basics. And if you memorize just this stuff right here, you can fluently move around in the command line and do a little bit. And when you need to do a little more, you can type man and learn how to do it. Okay? So it's not really that much. Like the number of letters here is pretty tiny. And I already showed you the history. The one thing I didn't mention, when you type history and see the list of commands, they have a number next to each one. If you put an exclamation point and then that number, it'll just rerun the same command again. So it can be handy. Quick illustration, if I type history again, I'll see all the commands that I ran before. And then if I do bang 126, that will run command 126 again. And it failed in the same way that it failed last time, because there's no -R option. Okay, it's just exactly like you type that command in again. These guys invented the stuff we're using right now, Unix. Yep, 60s. Old AT&T engineers in the 60s and 70s. Okay, I think this is a good summary to end with before we get into some more advanced things on Monday and then start talking about Git. So just some things that make this terminal very powerful in ways that you don't quite have with a graphical user interface. One, you have tab completion, so you could just start typing a few characters of a file name and hit tab, and it gives you the rest. That also works with commands. Like you can start typing the first few characters of these commands, or various longer ones and hitting tab, and that works. You can specify the files or directories using patterns, like regular expressions. So if you want to do something with, like, copy or remove all the files where the file ends with a digit, there's a way to do that, or it ends with a character in a certain range. So you have very sophisticated ways of specifying, I want to do something with this subset of the files in the current working directory. You can easily redirect the input or output of any of these commands or any other ones to a file. So you can make it so it runs the command like ls, and it sends the output to a file or to another command. That's the combining commands. You can also start running a program and then pause it and restart it and so on. And by the way, there's a lot of programs you can run here on the command line, like Sage. So I'm now running Sage on the command line. And then that'll just be something that's listed in history. Or R, the program R for doing statistics, is now running from the command line right here. If you're doing some sort of supercomputing or scientific computing, you'll inevitably end up doing a bunch of stuff with command line shells on some supercomputer somewhere, or some fast cluster somewhere. And there are thousands and thousands of commands, like we were just looking at. So just kind of as you leave, I'm going to type ls user bin, which will be a big list of commands. Will appear shortly. It's so big it took a while, but Maybe I'll make the screen super small. Okay. All right, so that's a couple of the commands that are available. All right, so I'll see you on Monday, where we'll finish talking about the command line and then start talking about Git. Hey.
I have a question about grading this homework.
Sure.
So, this
Although
part
Simon
should
is the
Okay.
expert on the grading. But
So-
what's the problem?
be, is this for sorted data or just for
Oh, it wouldn't matter whether it's sorted or not.
Okay, so
Because the points would look the same, I think.
yeah, but
Oh, I see
for,
what you mean.
for the sorted, the shape it should be the linear.
Yeah, I have that too actually.
Uh-huh.
Some people
You don't know
have
whether
it.
it should be sorted or not?
But
Yeah.
in the first part it said sort them, but
Yeah, so I
Okay.
think sorted.
I think either way would be okay.
Sorted is first. So.
Yeah. Well, actually, I think it's okay if it's like here you can sort it, but I think it's okay to do what they did.
Okay.
Like not, it doesn't have to be the sorted plot.
Thank you.
Yep, sure. Yeah, you're here
Yeah.
first.
So for our plot function for our class,
Mhm.
do we